show that the relation R on the Cartesian product of the set of natural number with itself, which is defined by the ordered pair A comma B, is related to the ordered pair C comma D if and only if A times D equals B times C for all ordered pairs A comma B and C comma D belonging to the Cartesian product of n with itself as an equivalent relation on the Cartesian product of n with itself. Okay, let us begin. So here in this problem, it's given here that R is a relation on n. So here we have R is a relation on the Cartesian product of n with itself. What does it mean when we say R is a relation on the Cartesian product of n with itself? That simply means that the relation R is going to be a subset of the Cartesian product of n with itself, where n is the set of natural numbers. Okay, and this relation is defined as, now it is defined as the ordered pair A comma B is related to the ordered pair C comma D if and only if we have A times D equals to B times C for all ordered pairs A comma B and C comma D belonging to the set of Cartesian product, the Cartesian product of n with itself. Okay, so this is given to us, and we need to show that the given relation R is an equivalence relation. So how do we show that it's an equivalent relation? All we have to show that the relation R is reflexive, it is symmetric, and it is also transitive. Okay, so we'll start with the first one. We will check whether if the given relation is reflexive or not. Okay, so how do we check that a given relation is reflexive? So here we know for a fact, we know that if we take the product of A with B, then this is equals to the product of B with A, because we know that since multiplication is commutative on n. Right. Now if we say that A times B equals to B times A, then we can also say that this simply means that this implies that the ordered pair A comma B is going to be related to the ordered pair B comma A, because it's given in the definition that A comma B, the ordered pair, is related to C comma D if and only if AD equals to BC. But in our case, we have the ordered pair C comma D that's given by B comma A. And this came from a fact that AB equals to BA. So what does it mean? So this means that A comma B is related to B comma A for all A comma B belonging to the Cartesian product of the set of natural number with itself. Okay, so we can say that the relation R is reflexive. Now we have showed that our given relation R is reflexive. Now we will go to the second part where we will show that R is symmetric. So this time we are going to check for symmetry. Now how do we check for symmetry? For this, let us consider two arbitrary elements. Let one of the element be A comma B and the other element be C comma D. So we're saying that these two ordered pairs belongs to the Cartesian product of n with itself. So here we are starting with two arbitrary elements such that if we take the ordered pair A comma B and say that it is related to the ordered pair C comma D, now what does it tell us? This tells us, according to the definition, that means we have A times D equals to B times C. Fine. Which means that we can rewrite it as BC equals to AD. Or in place of BC, we can simply write C times B. This is going to be equals to D times A. The reason we're writing C times B equals to D times A, this tells us that we can have C comma D. This is related to A comma B. So what we have done here, thus we have shown here that A comma B, if this ordered pair is related to the ordered pair C comma D, this simply implies that the ordered pair C comma D, that is also going to be related to the ordered pair A comma B for all ordered pairs A comma B and the ordered pair C comma D belonging to the Cartesian product of n with itself. Fine. So what does it mean? This means that so we can say that R is symmetric. So we have a symmetric relation here as well. Fine. And then finally, we are going to check for transitivity. So let's show that R is transitive as well. Now, in order to show that we have that the relation R is transitive as well, we're going to consider three elements. So each of them are going to be ordered pair. So let's say we have the element which is the ordered pair A comma B. Next, we consider another ordered pair C comma D, and we are also going to consider a third ordered pair E comma F. Let's say all of these ordered pairs belongs to the Cartesian product of n with itself such that we have A comma B, this is the ordered pair A comma B is related to C comma D, and we have the ordered pair C comma D related to the ordered pair E comma F. Fine. Now, what does it mean when we say that A comma B, that ordered pair is related to C comma D? This simply implies that A times D will be equals to B times C. We're simply using the definition, that is, take the first element of the first ordered pair A comma B and multiply it to that of the second element of the second ordered pair C comma D to get A times D, and this is going to be equals to the product of the remaining two elements in each of the two ordered pairs. So AD will be equals to BC. Then we'll again apply this same property of the relation to C comma D related to E comma F to get C times F equals to D times E. Now what we'll do, from AD equals to BC, let's do one thing. Let's isolate D. So D is simply going to be equals to BC over A. We're dividing both sides by A. Now we have CF equals to DE. So what we'll do, we'll take CF, we'll keep it as it is, and on the right hand side in place of D, we're going to replace it with BC over A, where B times C over A multiplied to E. Now here we can say that C is a common factor on both of the sides. So simplifying this gives us F equals to B times A multiplied to E. Let's cross multiply to get A times F equals to B times E. So here we have shown that AF equals to B. If AF equals to B, can we not say that A comma B, this is related to E comma F? So here we started out by considering, so let's write it down. So if the ordered pair A comma B is related to the ordered pair C comma D, and or the ordered pair C comma D is related to the ordered pair E comma F, then we were able to show that the ordered pair A comma B is also related to the ordered pair E comma F for what? For all values of the ordered pair A comma B, C comma D and E comma F belonging to the Cartesian product of n with itself. So this simply tells us, thus we can say that our relation R is transitive as well. This is also a transitive relation. Fine. So what? We have successfully showed that our relation R is reflexive, it is symmetric, and it is transitive as well. Hence, we can say, and finally, we can say that our relation R is an equivalent relation. So this is going to be an equivalent relation on the Cartesian product of n with itself. Hence proved.